So hello everybody and welcome to the Festival of Computing to 2021. Gosh, sorry, I couldn't get my words out there. This is a unique collaboration between the University of Plymouth and Computing at School. And this is our big data session with Marco. So my name's Shauna and I'm the outreach manager for the Faculty of Science and Engineering at the University of Plymouth. So I'm going to be your host today. And I'm also accompanied by Lewis, who is one of our student ambassadors. He'll just be moderating the chat, keeping an eye on any questions that come in. So if you do have any questions, do pop them in, and Marco has mentioned that he's happy to be asked them throughout. So if you did think of something really pressing, just let us know. So just a couple of housekeeping moments. If you could keep your video and microphone off, just for the ease of Marco and the other viewers as well. And you are being recorded as well, as this will be shared with you afterwards. So if you didn't want your face appearing, keep it off. So yeah, if you wanted to pop any questions in the chat box, there's just an icon for that below. Marco has also mentioned that throughout he will be using the thumbs up reaction buttons as well, which you can also find in the icons below. So if he asks you any questions, feel free to give us a thumbs up or a smiley face. So yeah, I will hand over to Marco and we can begin our session. So hello, Marco.
Hello, Shona. Thank you for the introduction and thank you everyone for attending my session. My name is Marco Palomino. I am a lecturer in information systems and big data. I am in charge of teaching a number of modules for students undertaking computing-related programs at the University of Plymouth. I am also a researcher, and some of the material that I will introduce to you today is closely related to my research activities at the university. I am the admissions tutor, so if you are interested in a career in computing and you are planning to apply for a position in Plymouth, then you are very welcome to get in touch with me. My email address is at the bottom of the screen right now. I am pointing it out with my laser pointer. So feel free to make a copy, make a note of my email address, and then you are very welcome to get in touch and ask me any questions you may have about admissions or about the things that we are going to discuss today. Just to make sure that you understand what I am saying, just to make sure that you are following my explanations, then during this session, I might ask you a couple of times to use your thumbs up icon and put your thumbs up icon on the screen. Just to make sure that you understand what I mean, I would like you to locate the dashboard on your Zoom windows. The dashboard is this rectangle that appears typically at the bottom of your Zoom window. And sorry, it's this rectangle I have here. And it is the place where you can locate certain buttons, like the one you can use to mute or unmute yourselves. Then there is a button to access the chat. And then it's another button for reactions. If you click on reactions, you should be able to see some icons. The second one is the thumbs up icon. So just to make sure that you understand what I mean, can I please ask you to put your thumbs up icon on the screen right now, just to let me know that you are there and that you are following the explanation. Excellent. Very good. So I can see my screen is now full of yellow thumbs. Thank you. Thank you very much for doing this. Thank you. Thanks for the feedback. So the title of the session is, just a moment, please. Right. The title of the session is If Romeo and Juliet Were Facebook Friends. And what we are going to do is to discuss a few things that would happen if that were the case. But we are going to do this in the context of big data and recommendation algorithms. Now, if you want to understand big data, then you need to begin with data. And if you want to work with data, then you have to begin with databases. But we cannot go any further without answering a couple of questions. The actual topic for the first section of this class is databases, but we cannot go any further without answering a couple of questions about databases. The first of these questions is, what are databases? And the second one is, why do we care about them? So I don't know how much you know about computing. I don't know how much you know about databases, but can I ask anyone in the audience to unmute yourselves and tell me what are databases, or perhaps put something on the chat to let me know what you think databases are? Please, any answers are welcome. So tell me, what are databases?
Programs that that catalog and index data, acting kind of as persistence, so that it can be stored and queried in computationally effective manners and accessed by other software.
Fantastic answer, James. You know a lot about databases. Very, very good. Is there anyone else interested in volunteering an answer? So what are databases for you? I mean, James' answer was really, really good. But can I ask anyone else to contribute as well? Any ideas? No? Okay, well, that's fine for the moment. Probably my favorite definition for the concept of databases is the one that you can see on the screen at the moment. A database is a collection of information that exists over a long period of time, often many years. And one of the reasons why I like this definition is because it is simple. Another reason why I like this definition is because it was created by a professor who works for the University of Stanford, the place where Google was invented. Google was originally a student project, and it was created precisely in the university where this definition was proposed. If you think about it, databases are powerful tools because they use computers to do exactly what computers do best. And this is store, manipulate, and display information. It has been estimated that more than 80% of all the computer programming work that is done globally is related to data. So if you are interested in a degree in computing, if you want to have a career in computing, then it actually makes sense that you start learning about databases, because they will become an important part of your professional life in the future. But even if you are not considering a degree in computing, you need to realize that computers are everywhere nowadays. Therefore, it actually makes sense for you to understand what databases are, learn how to make use of them, and how to get a benefit out of them. So, as I explained a moment ago, there are a couple of questions that we need to answer before going any further. The first of these questions was about the definition of databases. And with the help of James and the explanations that I have provided, we already have an answer to the first question. We now know what is a database. What is a database? But now, can I ask anyone to help me with the second question? So why do you think we care about databases? So please help me with that question. So why do we care about databases? Do you have any ideas? Please put something on the chat if you don't want to talk, or feel free to unmute yourselves and tell me, why do you think databases are important?
They
No
allow
ideas?
us to store and catalog large amounts of data.
Okay, so you think we care about them because they allow us to store and catalog data. Anybody else? No? Well, that's fine for the moment. Just a couple of moments ago, I said that computers are everywhere nowadays. And that's also the case of databases. And one of the reasons why we care about databases is because they are everywhere. Every time you get in touch with a friend on social media, for example, using Facebook, you are making use of a database. Every time you buy something online, for example, using Amazon, you are employing a database. Every time you watch something on YouTube or you search for directions using Google Maps, you are employing a database. So databases really are everywhere. Now, if you think about cars, car companies have existed for a very long time. They are actually very old. For example, Mercedes was founded 94 years ago. That's almost a century ago. Ford, another company, that was founded more than a century ago. But if you think about applications such as Facebook or Amazon or YouTube or Google Maps, these applications are relatively recent. The technology that powers these applications has only existed for about 2 decades. However, within 2 decades, these applications have managed to become part of our everyday lives. They are part of our daily activities. They are even part of our workplace. Certainly, the expectations we have nowadays about what computers and mobile devices can do have been shaped by these applications. Thanks to these applications, a great deal of content that is available online nowadays has been produced by the general public. And that means people like you and me who regularly tweet about the things we read and about the things we experience on our everyday lives. There is plenty of content that is produced by people like you and me who buy something online and then share a product review with other people. There is plenty of content that has to do with people like you and me watching something on YouTube and then deciding whether we like it or not. So some companies are actually making use of this information, this publicly available information. And what they do is they gather all of this information and then they keep it in databases where they can analyze it later on. And part of the analysis has to do with searching for patterns of information, patterns that are probably shared by millions of online users. And then they use those patterns to make predictions and make recommendations. And this is exactly where this session is going to become a little interesting from a practical perspective. Because what we are going to do is that I am going to provide you with some information. and I am going to ask you to search for patterns. And then we are going to make use of those patterns to make recommendations. And we are going to do all of this in the context of recommender systems. A computer system that makes recommendations is known as a recommender system. For example, Netflix recommends movies you may want to watch. Amazon recommends products you may want to buy. And Facebook recommends people you may know and you may want to get in touch with and you may want to become friends with. The actual algorithms behind companies like Netflix, Amazon, and Facebook are closely guarded secrets. And they are not going to tell us how their algorithms actually work. They are not going to make their algorithms publicly available. However, what we are going to do in this session is learn the basics behind recommender systems. And just for the sake of an example, we are going to do this in the context of Facebook. Now, once again, just to get an idea of how much you may know about the subject, what I am going to do is I'm going to ask you to put your thumbs up icon on the screen if you have a Facebook account. So if you have a Facebook account, please put the thumbs up icon on the screen. Okay, so apparently I have only 3 Facebook users in the audience. I don't believe it. Can I please ask you again to put your thumbs up icon on the screen if you have a Facebook account? Right, so probably I have 5 Facebook users on the audience. Okay, thanks for letting me know. And perhaps you don't have a Facebook account, but still I am guessing that you know what Facebook is, at least generally. Therefore, you are probably familiar with the idea of friends on Facebook. So if you have a Facebook account, then you are able to make friends on Facebook. And your friends are people you can get in touch with, people you can interact with. They can become your friends on Facebook. And Facebook regularly makes recommendations to you about new potential friends for you. So Facebook is continuously trying to identify people that you may know and you may want to get in touch with to become friends with them on the social network. So even though you may not have a Facebook account, can I please ask you to tell me how you think that Facebook identifies potential friends for you? How do you think that Facebook suggests friends for you? Do you have any ideas? They look at mutual friends. That's what James Waiting is saying. Viresh, they check your location, okay? Harry, people you have in common. Mark, similar interest. Edward, what photos you like. Sabrina, they look at your contacts. Yes, Sabrina, they may look at your contacts. Thank you for these answers. Yes, all of you are correct. So Facebook will try to look at your friends, at your existing friends, and then they will try to recommend other people who are friends of your friends. They might also look at your location, similar interests you may have with other people, perhaps your contacts. Viresh says they look at whose account you have looked at and how much time they have looked at. Yes, probably you are very, very right. So let me go back to my slides. And what I am going to do in a moment is I am going to read out Facebook's official line on how new friends are suggested on the social network. So remember, this is what Facebook claims. So according to Facebook, they make recommendations based on mutual friends, work and education information, networks you are part of, contacts you have imported, and many other factors. And it's probably the many other factors that are the most interesting one, considering how vague Facebook is. So we are not going to know how exactly the Facebook algorithm works, but what we can do is understand the basics behind recommendations. And I suggest starting with an example. So let us consider that we have a certain person on Facebook. So this is a person who has a Facebook account, and we are going to refer to this person as person A. And as it happens, A is friends with Scary, and she's friends with Sporty, and she's friends with Baby, Ginger, and Posh. So we have a certain person on Facebook, and we refer to this person as person A, and she is friends with the 5 ladies that we have on the screen right now. Now, let us consider a second person. This is a person who also has a Facebook account and happens to be friends with A. And this person B is also friends with Scary and friends with Sporty and Baby and Ginger. And that's it. So to summarize the situation, we have a person A who is friends with the 5 ladies we have at the top of the screen at the moment, and then a second person, person B, who is friend of 4 of those 5. So if you were to recommend a new friend for B, then who would you recommend? Please feel free to unmute yourselves or put something on the chat. So we want to recommend a new friend for B. So who would you recommend? So Viresh says Posh, Sabrina says Posh, and yes, you are right. So given that person B already shares 4 of the 5 friends of person A, then it stands to reason that the 5th of those friends might also be a friend of person B. So perhaps B also wants to be friends with Posh on Facebook, given that she already shares 4 of the friends that A has. So let me quickly go to the chat to no Viresh, because we are assuming that they are already friends with each other. So we are already assuming that A and B are friends. So we are not going to recommend them to each other because they are already friends with each other. Now, just to reiterate this idea, let's do another example. It's a very similar one. So we have a person A, and this person has a Facebook account, and he is friends with John, Paul, George, and Ringo. And then we have a second person, person B, who is already friends with A, and B is friends with John, Paul, and George. So if we wanted to recommend a new friend for person B, who would you recommend? You already know that B shares 3 friends with A. So who would you recommend as a potential new friend for person B? And Viresh says Ringo. Right, I agree with you. And the reason is that B already shares 3 friends with A. So it stands to reason that Ringo might also be a friend of B, or B might also be interested in getting in touch with Ringo, given that he already shares 3 friends with person A. So can I ask you to put your thumbs up on the screen if you are following the explanation? If you don't have any questions about the things that I have just been discussing with these 2 examples, could you please put your thumbs up on the screen? Excellent. So I can see a number of thumbs up on the screen. If you have any questions, please feel free to unmute yourselves and ask. But for the moment, I will carry on assuming that you are happy with the explanation. So you realize that in this particular case, at least for this particular example, Ringo would be a good friend recommendation for B, given that B and A already share 3 friends in common. Perfect. Perfect, and congratulations, because what you have just learned is the most basic algorithm behind recommendation systems. This is an algorithm that is known as collaborative filtering. And the collaborative filtering algorithm is based on the following premise. If A has the same opinion as B on a certain issue, then A and B are more likely to share an opinion on a different issue than randomly chosen people. And what I have on the right is another example, simply on a different context. So we have a couple of people, and we are assuming that they are similar. And they have already read 2 books in common, the green book and the red book. So the moment one of them reads a new book, that new book becomes a recommendation for the second person. Why? Because we are assuming they are similar and they share already 2 books in common. Then it stands to reason that a third book read by one of them can be of interest to the other person. And you can extend this concept, you can extend this idea to any other example. I have here one about people who are into sports. We are assuming they are similar, they both like sports, and they both like pizza and salad. So the moment one of them becomes interested in a particular drink, that drink becomes a recommendation for the second person. Why? Because they are similar, they already share 2 things in common, then it seems reasonable to assume that a third thing that has now become relevant for one of them can be a good recommendation for the other person. Once again, can I ask you to put your thumbs up on the screen to check that you are following the explanation and that you are happy with the ideas that I am proposing? Excellent. So I can see a number of you using your thumbs up. Excellent, fantastic. Thank you very much for letting me know that you are following the explanation. And then what we are going to do next is I want you to think about Romeo and Juliet. So let's consider the tragedy of Romeo and Juliet, which is all the way back to the 16th century. So we are talking about a tragedy that was published for the first time in 1597. In this tragedy, Romeo is originally interested in Rosalind, but then the moment he meets Juliet, he falls in love with her. Shakespeare will take every opportunity to question Romeo's love, but Romeo is going to extremes to prove that his love for Juliet is for real. He will take abuse from people like Tybalt and the Norse, but he's happy to do that because he rather dies than live without Juliet. So in this diagram that I have on the screen, I have put in orange the characters that belong to the house of Montagu. Montagu is Romeo's father. And the three characters that belong to the house of Montagu appear in orange. Then I have put in pink the characters that belong to the house of Capulet. Capulet is Juliet's father. The ruling house of Verona appears in green, the Franciscans appear in purple, and the Norse who works for Juliet appears on blue. Excellent. So in this diagram, I have created a link between some of the characters because I want you to assume that these characters have got Facebook accounts, and we have a link for those characters who are already friends with each other. So, for example, Romeo is already friends with Juliet. And friendship is a relationship that goes both ways. So if Romeo is a friend of Juliet's, then Juliet is a friend of Romeo's. And that's the reason why the link connecting Romeo and Juliet has an arrow on each side. For example, Friar Lawrence is the person who continuously listens to Romeo and tries to advise him. So there is already a connection between the two of them. We can assume they are friends. Benvolio is Romeo's cousin, so they are already friends. Mercutio is Romeo's best mate, so there is a link between them. What I provided for you was a handout, and I am going to put on the screen the document that I provided for you. Just bear with me a second to get my computer ready. Okay, so the handout that I provided for this session is a document that contains the same picture that I was showing to you a moment ago, but I have circled Mercutio. I've put a red circle around Mercutio, and the reason is because I want to concentrate on Mercutio, and I want you to identify friend recommendations for Mercutio. If you go further down in this document, you are going to find a table. And in this table, I have listed Mercutio, followed by every one of the characters in the tragedy of Romeo and Juliet who are not yet friends with Mercutio. For example, Romeo is not in the table because Romeo is already friends with Mercutio. But Benvolio is listed in this table because Benvolio and Mercutio don't have a direct link. So they are not friends with each other yet. And then what I have done here is identifying the friends in common between Mercutio and Benvolio. Okay? So what you need to do is to look at the links in the diagram and check that in this particular case, Romeo is the only character who is friends of Benvolio and Mercutio at the same time. If we look at Mercutio and Capulet, there is no direct link between them, so they are not friends yet, but they share two friends in common, Paris and Prince Scalus. And that's why I added here. And then the final column is simply to count the number of friends in common. So can I please ask you to fill in this table? I'm going to give you a couple of minutes to do that. So I hope you have the handouts with you. We provided them in advance of the session. So please fill in that table. And when you have finished, please put your thumbs up icon on the screen so that I know that you have completed the exercise. Can I just check that you have the handouts ready? So please put the thumbs up on the screen if you have got the handout. Excellent. Okay. Thanks for letting me know. Okay, good. So you can work on this. So I'll give you a couple of minutes to fill in the table. All I need is to know whether to know whether you have finished with the table, and that means simply identify the friends in common for each pair of characters on the table. So it's Mercutio plus another character who is not yet a friend of Mercutio's. And then when you are ready, please put the thumbs up on the screen so that I know that you have finished the exercise. Excellent. So shouldn't take long. Okay, 2 people have already finished. So Biresh and Lucy, you have completed the exercise. James and Joseph have done the exercise as well. Anybody else? Please put your thumbs up. Okay, I've got more thumbs up on the screen. Fantastic, fantastic. Okay, so 3 more people have just completed. Sabrina and Nick have now finished. Fantastic, fantastic. So if you have already finished with this table, then I hope what you have got is what I have just put on the screen. So I have just put the solutions to this exercise. Remember, collaborative filtering is the name of the algorithm that we are following in order to make recommendations for Mercutio. And the table should contain the information that I have put on the screen. So Mercutio and Friar Lawrence have only one friend in common, and that's Romeo. Mercutio and Juliet have only one friend in common, and that is Romeo as well. The Norse and Mercutio don't have any friends in common, so they have 0 friends in common, and same thing for Mercutio and Thibaut. Fantastic. So just to double check, can you put your thumbs up on the screen if you got the same answers that I did? Okay, so so apparently all of you got the answers correct. Very good. That's excellent. So what can you tell me now about friends in common? Well, remember what we are trying to do is, or what we wanted to do was to find friend recommendations for Mercutio. So some observations that we can make after this exercise is that we were looking for mutual friends, and then a friend of one of your friends is likely to be a good recommendation for you. However, if we are able to identify someone who shares many friends in common with you, then that person is likely to be a better recommendation. So we may say that the best friend recommendation is the person with whom you have the largest number of mutual friends. In this context, then, who is Mercutio's best friend recommendation. So who do you think that would make the best friend recommendation for Mercutio? So Romeo, well, no, no, Viresh. Romeo is already a friend of Mercutio, and because he is already a friend of his, then we cannot recommend him as a potential friend. But John Kim has provided the answer that is correct. So if we based our recommendations on the number of common friends, then definitely Capulet and Montagu are the best friend recommendations. And the reason is simply what we get in this table. So the two characters with the largest number of common friends are precisely Capulet and Montagu. And that's why we are going to consider both of them as the best friend recommendations we can make for Mercutio. So yes, Viresh, I agree with you. And yes, Ajahn Kim, I agree with you. Excellent. So now, is this algorithm perfect? Is this algorithm good enough? Well, one more question before I go any further. So we have identified the best friend recommendation for Mercutio, but what would be the worst friend recommendation for Mercutio? So who do you think that can definitely not be a friend of Mercutio? The Norse, says Sabrina, and Viresh says Thibault and the Norse. Excellent, excellent, very good answer. So those two characters are the worst friend recommendations for Mercutio because they don't have any friends in common. The other thing is, well, if you know the tragedy of Romeo and Juliet, then the Norse and Thibault hate Romeo, so they cannot be good friend recommendations for Romeo's best mate, who is precisely Mercutio. So everything seems to happen according to the story, according to the tragedy of Romeo and Juliet. So the results seem to be sensible in the context of the tragedy. But I was asking you, do you think that there are any disadvantages in this approach? Do you think that this algorithm is perfect and can always help us to identify friends or potential friends? What would you consider a disadvantage of this algorithm? For instance, maybe someone like Sabrina or Viresh or Ajahn Kim. What can you identify as a problem with this algorithm? What do you think is probably not going to work well in the long run with this algorithm? Yes, Viresh, please unmute yourself and let us know.
If there's new users, they'll have a lack of information, so they can't really do much with the algorithm.
Oh, fantastic answer. I really like that. Yes, so you probably know a little more than some of us about recommendation algorithms, and that's the reason why you have said this. So if we don't have enough information about certain characters or certain users on Facebook, we are not going to be able to make good recommendations. But don't you think that there are other issues apart from that? Let me give you an example that I think is going to show that this algorithm, although it is the most fundamental algorithm, is not that good. And very quickly, because we are running out of time, but let me propose the following situation. So let us assume that you are friends with 2 people on Facebook. So you have only 2 friends on Facebook. And those 2 friends are J.K. Rowling and James Corden. So those are your 2 friends on Facebook. And now, as it happens, J.K. Rowling is a very selective person. She has only 2 friends on Facebook, you and someone else. So imagine how selective she is. She has only 2 friends. And also imagine how much in common you must have with that other person who is friends with J.K. Rowling, because only that person and you are friends with her on Facebook. So you must have a lot in common with that other person. On the other hand, James Corden is completely indiscriminate. So he accepts everyone as a friend on Facebook. James Corden has 7 billion friends in Facebook. If you are on Facebook, then I'm sure you are friends with James Corden because he accepts everyone as a friend. Now, if well, J.K. Rowling and James Corden have no friends in common apart from you. So you are the only common friend between these 2 people. So if we wanted to recommend a new friend for you, who would you recommend? The only other person who is friends with J.K. Rowling, or any one of the 7 billion friends of James Corden. So if you were to identify a new friend recommendation for you, who would you choose? Any ideas? Please unmute yourselves if you have the answer. So I want to make a friend recommendation for you. Who should I choose? The only other friend of J.K. Rowling or one of the 7 billion friends of James Corden? Yes, Virish, please go ahead. Oh, I thought you had your hand up. Anyway, anybody can give us the answer?
The one mutual friend with J.K. Rowling would seem like a better option, more likely of success.
Excellent, Zach. Why? Why did you think that could be the better option? And I have something on the title of this slide. So are all friends equally important, or do you think that certain friends are more influential? Well, the truth is that certain people are more influential on a social network. And when I say influential, I don't mean to say they are celebrities, or they are on telly, or they are very famous writers. No, when I talk about influential, I mean to say they are for some reason important in the network and they are close to you. And because of that, then after collaborative filtering, another algorithm was invented. And this algorithm is now known as influence scoring. And in this algorithm, we make use of a formula to identify how influential a person is. And then we make recommendations based on that particular formula. So the formula is meant to tell us exactly a number that is going to identify how influential a people is, or a person is, in the social network. And then, for example, the only other friend of J.K. Rowling, according to this formula, is far more influential than any one of the friends of James Corden. I won't have a chance to go over all the details of this algorithm because we are finishing this off, but I just wanted to provide you with a summary of the things that we have covered today. So Databases, remember, they are powerful tools because they make use of computers to do exactly what computers do best: store, manipulate, and display information. Computer systems that make recommendations are called recommender systems. And in this session, we have covered two algorithms, mostly one, the first one, collaborative filtering, but at least I had a chance to provide you an example that suggests that the first algorithm is not ideal. So we definitely need another one to improve the results. And that second algorithm is known as influence scoring. So can I please ask if there are any questions at the moment? James Stone, the algorithm should take into account the number of friends an account already has. Yes. So, well, that is involved in the formula for the influence scoring. So yes, James, you are correct. Can I please ask anyone else? Viresh, I don't know if you have a question because your hand is up on the screen, or you just forget to switch off the hands up icon. Okay, thank you, Viresh. Can I ask anyone if you have any questions for me at the moment? Anything about databases or the things we have covered in terms of recommendation algorithms? No? Okay, so Shona, if you are around, I don't know if you want me to give you the floor, or what should I do now?
No, that's fine. Unless we've got any questions coming in, Marco. That was great. I really enjoyed that. Throwback to the Beatles and the Spice Girls.
So I've got a question for Viresh that is actually very, very good. So yes, Viresh, Facebook, at the moment, for sure, they are not using one database and they are not using one algorithm. We may not know exactly what they do, but for sure, they are employing several databases and they are employing several algorithms. So one of the things that we do in university, in one of my modules, and one of the things that researchers do continuously is to create something that is called hybrid systems or hybrid algorithms. Sometimes they are known as ensemble approaches, in the sense that they combine together more than one algorithm. And the idea is precisely to find the best way to combine them. So sometimes, rather than running two algorithms simultaneously, what people would do is run one algorithm, and once you get an output for that algorithm, use the output of the algorithm as the input for the next algorithm. So you don't get them working simultaneously, you get them working one after the other. Sometimes what people would do is to give a weight to the algorithm. So people will say the first algorithm is worth 80% of the final result, whereas the second one is only 20% of the final result. And then there are also cases where you simply run both and then you look at the intersection of the results. So those results that have been provided by both algorithms are likely to be better than others simply because more than one algorithm has chosen them or has produced them as results. So I hope this answers your question, Viresh. Shona, I don't know if okay, Sabrina, for influence scoring, what is the influence score for after it has been determined? Okay, so Sabrina, I didn't have a chance to go over this with Romeo and Juliet, but ideally what we would like to do is to apply the influence scoring for Romeo and Juliet. And the idea is the characters with the highest scores are going to make the best recommendations. So you have to consider, again, pairs of characters, for example, Mercutio and Capulet, Mercutio and Montagu, and then calculate the score of Capulet as a potential friend for Mercutio, or the score of Montagu as a potential friend for Montagu. And then the one with the highest score is likely to be the best friend recommendation. Yes, Luis, sorry, I am running out of time. So, well, I don't have any more time to go over any more questions. Please, you have my email address. So if there is anything that you would like to ask, feel free to get in touch by email. Shona, thank you very much for the opportunity to participate in the event.
Thank you for joining us, Marco.
For attending my session.
Cool. Thank you, everybody. I hope you have a lovely rest of the day. And you too, Marco. I'll see you soon.
Excellent. Thank you.
Bye.
Bye.